Hi, everybody. I'm Laurie, Head of Developer Relations at Arize AI. I have been a developer for 30 years, and in a former life, I co-founded NPM Inc., so some of you may know me from that world. These days, I spend most of my time thinking about what it takes to build AI systems that actually work by testing them with evaluations. What am I talking about today? I'm talking about agents and how to make them useful and efficient, which is important because we're all using them every day. Specifically, I'm looking at how we give them tools. There are two very popular ways to do that, MCP and the command line via skills files. I'm going to talk about which one is better and when and why. But instead of having just a hot take, I'm going to use Arize-powered evaluations to put some actual data behind it. Then we'll look at that data and figure out what it's telling us as we should do. So first, what is MCP? I want to be crystal clear about what it really is, even though you've probably heard of it before. It's a protocol for agents to use remote tools with a very useful built-in discovery mechanism. It is super popular. The SDKs get nearly 100 million downloads every month, and there are over 17,000 active MCP servers that we know about. On the other hand, what's a skill? A skill in the anthropic sense is a markdown file. It sits on disk and it tells the model how to do something. Often that means how to use a particular command line tool, but it could also be how to call a particular REST API or how to follow your team's code review process. The agent loads the markdown into its context, and then it just does the thing. Effectively, it is another discovery mechanism for remote tool use. There's no protocol per se. The agent is just following natural language instructions, which give it the context on how to use the tools, the same way MCP does, just much less structured. Skills are also super popular. Skills.sh lists over 90,000 skills, some of which have been installed millions of times. But those numbers alone aren't enough to tell the story because not every skill is about remote tool use. 6 months ago, MCP was the hot new thing. Everybody was building MCP servers. Then Anthropic, who also invented MCP, launched Claude Skills as well, and the discourse took a sharp turn. My friend Simon Wilson, who writes a lot about AI, said in October of last year that Claude Skills are awesome, maybe a bigger deal than MCP. That's a pretty spicy take for a guy who doesn't usually do spicy takes. And then in February this year, a blog post titled MCP is Dead, Long Live the CLI hit the front page of Hacker News and stayed there for 2 days. The argument was simple. LLMs already know how to use CLIs, so give them a shell and some docs. Stop building servers, stop writing schemas, just let them type commands. And just to pile on, Peter Liebels, Levels.io on Twitter, said in March, MCP is dead, just as useless of an idea as LLMs.txt was. It's all dumb abstractions that AI doesn't need, which is 2 piping hot takes in 1. This is, so far, a very online debate, mostly vibes and tweets and bold claims about which pattern is better. I wanted some actual data, so a few weeks ago I sat down and ran a proper evaluation, and because a good eval is tricky to get right, it took me a couple of weeks to get them right. But I think I have some pretty useful numbers now. Here's the experiment I'm running. I took one model, Claude Opus 4.6, because I don't pay for my tokens, and gave it a set of tasks to perform against GitHub using the Claude Agent SDK, the same thing that powers Claude Code. Same agent, same tasks, same repo to work on, but using different skills, 2 different skills in fact, or using GitHub's MCP server. Why GitHub? Because lots and lots of people use it. It's a really relevant test for the audience of this video. You are probably already using an agent to interact with GitHub. GitHub also already has a really mature official MCP server, a reference quality implementation. Or is it? We'll talk about that in a bit. And GitHub also has GH, which is a legitimately great command line tool. So both sides of the debate get their best shot, and it's the fairest possible fight. Or is it? Like I said, more on that later. To have something to test against that didn't blow up an actual GitHub repository that I care about, I built a fake Python SDK called Acme SDK Python, and I pushed it to GitHub. I created 12 open issues with realistic labels, 3 pull requests, 1 approved, 1 with no reviews, 1 draft, milestones, comments, assignees, all sorts of stuff. The code itself doesn't matter. What matters is the state of the repo, which is what I'm asking the agent to inspect, analyze, and modify. Fun fact, I initially made the repo public, but as soon as I did that, some random person's GitHub agent showed up, saw an issue marked good first issue, and started submitting PRs trying to fix my totally fake code. This completely messed up my tests by changing the state of issues without me doing anything, but at least I can say that this was a convincingly real repo. Then I wrote 25 tasks across 4 tiers of difficulty. Tier 1 is trivial reads. How many open bugs are there? Single call stuff. Tier 2 is harder reads. List all bugs and check if each has a linked PR. Tier 3 is writes. Create an issue, fix a typo via a branch and PR, add a label. This turned out to be the hardest level, even though I also invented Tier 4, which is complex analysis. For each milestone, report completion percentage, find all multi-label issues and tell me the most common pairing. That kind of stuff. Stuff you can't answer with a single command. Then I wired up 3 versions of the agent. I'm going to call these the 3 arms of the experiment, arm being just an A/B testing word for a variant you're comparing. The first arm is MCP. The agent gets the official GitHub MCP server and is firmly instructed to use it and only it. Of course, will it listen to my instructions? Agents are tricky. The second arm is a GitHub skill I pulled from LobeHub, which is a popular marketplace for finding skills. This skill is an encyclopedic reference, 2,187 lines of markdown. Every GH command, every flag, organized like a man page. It's comprehensive. But then I thought, what if I picked a bad skill? There are tons of GitHub skills out there. So the third arm is a different skill from a registry called Claude Skills Vault. I picked 2 skills that look very different. The Vault skill is 341 lines, 6 times shorter than LobeHub's. The Vault skill is opinionated and prescriptive. It sorts every GH command into 4 safety tiers, safe, right, destructive, and forbidden, with explicit rules about when to use each. So it's a playbook, not just a reference. The rules are the same for every arm. They get the same Claude-powered coding agent, the same base system prompt, the same turn budget of 25 turns, and the same very capable model. The only thing that changes is the tooling instructions. Before I get into how I did the evals, for those who aren't familiar with evals, I should explain what they are. Basically, they're tests. With regular deterministic code, you can write deterministic tests. I put in 2 plus 2 was the answer 4, pass or fail. With LLM-powered agents, things are more complicated. If you ask an agent to summarize a document, there are a million answers it could give you, and many of them would all be correct. And it answers differently every time. A human would know if the answer was good, but humans don't scale, and they don't run in CI. The way to handle this kind of non-deterministic output is to use a tool that's really good at handling messy inputs, which is to say another LLM. This pattern is called LLM-as-a-judge, and it's part of what Arize AI does. It provides a framework that lets you run these evaluations. Evals give you a way to objectively measure how well your agent is doing so that you can make your agent better. Which brings me to a very quick plug for Arize. Arize provides you with a bunch of tools, a way to capture logging data from your agent, called traces, and a UI to inspect those traces in detail. You can also run evaluations against those traces, so you can test if your agent does what it's supposed to. You can either run them after the fact, or you can plug them into your production data and run them online continuously so you know if your production agent goes off the rails. More directly relevant to this discussion, however, Arize also lets you take a sample of agent data called a dataset and run the same set of tests against it multiple times, changing some variable each time. That's an experiment. You can then track how your changes change the outcome of the task in a nifty little UI. So to test my Claude agent, I used 5 metrics. Correctness is measured by LLM-as-a-judge. I wrote down the real answer for every task, and an LLM judge compared the agent's output to the truth and scored it. Output quality is also LLM-as-a-judge. Is the final response well formatted and useful, not just factually correct? Latency is not an LLM judge. It's just total wall clock time measured in seconds. And cost is also a basic metric that I get for free from Arize. How much did it cost me in total tokens used? Latency and cost metrics are something Arize gives me for free, but as we'll see, they're very important for any agent. The last test is tool fidelity. For each arm, I defined an allow list, MCP tools for the MCP arm, bash and file tools for the skills arm, and tool fidelity is the fraction of calls that stayed inside of that list. Then I ran it. 5 full passes through every task, every arm, all logged to Arize AX. a total of 500 tests, each taking several minutes, which added up to days and days in the end because my initial tasks had some bugs and I had to reset the repo back to initial state after every run. And also, Claude had been having some uptime troubles recently, so I lost whole runs because Claude would hang. So let's look at these results, starting with the most important measure. Did the agent get the answer right? The answer here is fairly good news for everyone. Everyone got things mostly correct overall. I would have preferred more than 90% correctness, honestly, but everyone's in the mid-80s. But remember, I made these tasks deliberately tricky. On tiers 1 and 2, which were all reads, correctness was actually 100%. Everybody nailed it. Tier 3 involved writes, which turned out to be a really tricky part. You can see that I broke out tier 4, which is supposed to be the hardest tasks, but they actually did slightly better than tier 3. But the core conclusion is that they were all the same. No matter what kind of tool you use, your agent is going to get it eventually. But eventually turns out to be the key difference. When you look at latency and cost, the story changes a lot. Latency in this test is way higher for MCP. MCP is taking way more turns to get the task done, more than twice as many turns, about 12 calls per task versus 5 on the complex tier 4 tasks. And because it's taking more turns, it's using more tokens. Every turn takes the context from the previous conversation and feeds it back into the context window, so taking more turns really compounds the cost. This looks really, really bad for MCP. There are some extenuating circumstances, though. One is that the MCP server from GitHub is less flexible than the API that the GH command provides. Instead of getting all issues for a milestone in one call, for instance, it has to call once for open issues and once for closed issues. But another is structural. The response MCP gets is extremely verbose JSON, and the output overflowed the agent's context window. So when using MCP, the agent had to call again and write the output to disk, and then it had to use bash commands to parse through the JSON. One of the really great things about using LLM-as-a-judge to do testing is that you don't just get binary test results. LLM evaluations come with an explanation field, so every single test came with a little buddy who watched exactly what happened and wrote it down for me. I was then able to read these explanations to get full visibility into what went wrong. This is amazing because it means LLM-powered evals don't just measure how good your agent is, they also tell you what to do to make it better. In the early stages, this was mostly the LLM telling me that I'd messed up my testing harness somehow, but eventually it became explanations of how exactly the agent was behaving in real tests. One particularly egregious example was task 22. Find issues opened and closed in the same milestone and compute the average time open to close. Vault, on average, got it done in 7 tool calls, under a minute, 19 cents. MCP, on its worst run, took 71 tool calls, 8 minutes of wall clock time, and burned $2. But the real surprise was that only 3 of those 71 calls were actually MCP tools. The rest was MCP giving up and using bash to parse JSON files that it had written to disk. So not only was MCP taking really long, it was also cheating and using the command line anyway, even though I told it wasn't allowed to. I anticipated this possibility, which is why we have a specific metric for tool fidelity. Did it actually use the tools it was supposed to? The more complex the task, the more the MCP API wasn't enough, and the worse the tool fidelity got. Now, from a practical viewpoint, this doesn't really matter. You don't care if your MCP-powered agent uses bash sometimes, so I'm not really counting this against MCP for the eval, really, but it's certainly indicative of a problem. The fundamental issue with MCP, or much more accurately, with the GitHub MCP, is that it's a fixed API surface. When there's an API call that does what you need, it works absolutely perfectly in one shot. But if you need to do something not part of the API, like make 2 calls and join them and then filter, there's no way to do that in the API. You can do that on the command line because bash is Turing complete. So that's how all 3 arms solved the problem. But it meant that MCP was making extra calls all the time to achieve the same result. But sometimes it went the other way. Task 13 was to create a branch and open a pull request. MCP averaged 8 tool calls in 33 seconds, about 16 cents. LobeHub, the skill with all the context, averaged 22 calls, nearly a minute and a half, and almost 50 cents. When the task maps cleanly to an MCP tool, MCP calls create branch, create pull request, and then it's done. This is the shape of task that MCP was designed for. But despite that exception, based on this data, our conclusion should be obvious. The command line wins. Skills are better than MCP. Drop the confetti, strike up the band. Even MCP was using the command line to actually get the answers, right? Well, turns out the truth is a lot more complicated, or this would have been a very short video. The first problem is that GitHub is really famous, so the GH command line tool exists on tons of web pages and tutorials and Reddit and Stack Overflow answers. What happens if I don't use a skill at all? What happens if I just let the agent use its existing training data? Here's those tests again, now with a fourth set, using an agent with no skills or MCP instructions. And let me tell you, realizing I had to add a fourth set of tests when I thought I was done was really disappointing. It turns out Claude is already great at using GH. At Correctness, there's barely any gap between the skills, and just letting Claude do its thing. In fact, Claude is very slightly more correct when you don't give it any instructions. When I looked at the traces, that turns out to be because the skill told it to be careful running dangerous GitHub commands, while Claude by itself doesn't care about that and just ran commands willy-nilly without waiting for permission. On latency and cost, the story is more nuanced. MCP is still looking really bad, but both skills do better on latency than Claude baseline. They use fewer turns because they use the commands more correctly. LLM-as-judge, the really verbose skill, does worst on cost because it's burning more tokens because it's so verbose. But the vault skill, the short finely tuned one, does a bit better than baseline on cost. So skill does make a difference, and skill quality also makes an appreciable difference, even with a super well-known tool like GH. But that's a really important point. The cost of MCP is partly because it uses more tokens, and the reason it uses more tokens is because it's including a ton of context in every turn. Context that it turns out, for GitHub at least, the model mostly doesn't even need. But your company's CLI isn't going to be like that. Your company is probably not quite as famous as GitHub. So a model isn't going to know the parameters to your CLI. It might take a lot of turns getting it wrong, or it might not be able to figure it out at all. You might need the extra context that MCP provides. The next confounding factor is that MCP is not supposed to be just a thin wrapper to your REST API, although a lot of MCP servers do just that. MCP is a really rich protocol. In addition to tools, it can provide resources and prompts that help you use the tools. But more than that, an MCP server can have a whole agent behind it. An MCP server can be anything. Instead of making calls for open and closed issues and then making calls for issues by milestone and then having to filter the resulting JSON files, the MCP tool could have been natural language. Ask me to find and filter issues for you. And an agent on GitHub's side could have done all of the work. MCP is an LLM-first protocol, and it's designed for agents to use as natural language. The whole task could have been two agents collaborating. GitHub's MCP isn't designed that way, but there's no reason that it couldn't be, and there's no reason that your MCP server can't be. So that changes the story considerably. And finally, there's an elephant in the room, which is auth. CLIs are inherently developer tools. GitHub's a developer tool, so that's fine. The average GitHub user is not going to have any trouble generating an API token and passing it to the GH tool. But LLM users are the whole world, not just developers. Agents these days are used by everybody, and asking the average user to generate an API key is pushing it, and asking them to open the terminal to paste that key into a config file is just not happening. Your agent is probably not going to be able to figure out how to do it either, because auth is so different from tool to tool, and even if it did, the level of access control provided by your average CLI is wildly different from what an enterprise admin would expect to be able to control. MCP, on the other hand, uses OAuth. It uses OAuth so extensively that they actually extended the OAuth spec so that MCP could do all the things it needs to do. And the result is actually a really great experience. You tell an agent where an MCP server is just by pasting the URL of that server into your agent, and it will be able to automatically discover it, connect to it, and pop up a nice friendly browser window where you give it permission to access the service, and then everything just works. This takes MCP from a developer tool to a consumer tool. The command line is, for a lot of users, simply a non-starter. OAuth also allows enterprise administrators to finally control who and what gets access where, in a way that most API key auth does not. So, is MCP dead? I don't think so. If you are a developer using a developer tool, the evidence is strongly in favor of skills, especially if you are using a widely popular service. That's the narrow conclusion that you can draw from this data. If you're using an internal tool, a skill may be better than MCP, but it's going to need to be a very carefully written skill, not just a dump of every command and flag. But the overwhelming majority of agent users are not going to be developers. Agents in 2026 are a regular consumer product used by people who use Claude and ChatGPT. MCP is not just the best option for them, it may be, practically speaking, the only option. They're simply not going to install command line tools, they're not going to use API keys, and so their agent isn't going to either. Which brings us right back to the beginning. MCP versus the command line. After all that research, it turns out to have been the wrong question. The right framing is MCP plus command line. Real agents use both. Claude Code uses both. Cursor uses both. Your agent should probably use both. Use the CLI when you're working locally, when the tool has decades of training data behind it, when auth is pre-configured, and when you benefit from piping things together. This is the automating my own workflow case. Use MCP when the tool is remote, when it's proprietary and not in the training data, when you need OAuth and per user auth, when there's real state to manage across steps, or when you want to hide a whole agent behind what looks like a simple tool call. This is the shipping this to customers case. My headline findings are still real. MCP collapses on open-ended analysis work, 6 times the cost on the hardest tasks, 5 times the latency. Skills help a little. A short opinionated skill beats a long encyclopedic one, but for a popular CLI like GH, the training data is doing most of the work. But MCP is not the loser of this story. Testing with evals did what testing should do. It showed us the limits of our original question. Our job as engineers is not to pick a winner in a Twitter debate, no matter how satisfying that might be. It's to use the right tool for the job. If the model knows your CLI, you're running as one user with one set of credentials, and your tasks are composable, use the shell by all means. If your tool is remote, proprietary, needs real auth, or hides an agent, use MCP, and in most real systems, the answer is going to be both. I hope this has been a useful look into what tools you should actually use and when, and I hope it gives you some insight into how evals can help to measure LLM-powered software. All of the code and the data is open source on GitHub. That's all I've got for you today. Thank you very much for your time and attention.